Hello everybody, last video we have completed on qualitative electrolysis. Next I am going to explain about quantitative electrolysis. So first, what is the meaning of quantitative electrolysis? Quantitative electrolysis means the study of amount of substance at cathode and anode in electrolytic cell in terms of mass, volume, number of moles. Means how much, when we are passing electricity through the electrolytic cell, how much mass it was deposited on electrodes, how much volume of gas it was deposited on electrodes. So these information was given by quantitative electrolysis. So these quantitative electrolysis was explained by one of the scientists. The scientist is Faraday. Faraday, he was given two laws. In that, one is Faraday first law and Faraday second law. In that, Faraday first law is nothing but the amount of substance deposited on electrode is directly proportional to the amount of substance deposited or liberated is directly proportional to quantity of electricity. Means what we can write? So here we can write the weight of substance is directly proportional to quantity of electricity. So here quantity of electricity means, so that is the charge in terms of coulombs. Now if you remove the proportional, we will get the one constant W equal to, we can write Z into Q. So here Z is nothing but electrochemical equivalent. Now see here, Q is nothing but charge in terms of coulombs. Already we know 1 electron charge equal to 1.609 into 10 to the power of minus 19 coulombs. Then 1 mole of electrons charge equal to how much in coulombs? So 1 mole of electron equal to 1 electron charge is 1.609 into 10 power minus 19 into 6.023 into 10 power 23. So here we will get 96, approximately we will take 96,500 coulombs. Means 1 mole of electron charge equal to how much? 96,500 coulombs. Now see here, so here Z is nothing but what? Constant. So that is what we have to call electrochemical equivalent. So what is the meaning of electrochemical equivalent? So here when we are passing 1 coulomb charge or when we are passing 1 ampere current in 1 second. So here Q equal to what we can write? What we can say? I into T. I is nothing but current and T is nothing but time. The time we must take in seconds. So now let me explain how can we define the electrochemical equivalent. So when we are passing 1 coulomb charge through the electrolytes, so whatever the mass deposited on electrode, so the mass we have to call electrochemical equivalent. Or when we are passing 1 ampere current in 1 second through the electrolytes, so here the weight deposited on electrode, whatever the weight deposited on electrode, the weight we need to call electrochemical equivalent. So when we are passing 1 coulomb, so then if Q equal to, if you take 1, then Z equal to what? W. So these W we need to call electrochemical equivalent. Next I equal to 1 ampere current in 1 second, means at that time Z equal to what we can say? W. The W is nothing but what? Electrochemical equivalent. The weight is nothing but what? Electrochemical equivalent. Let me take one example. For example, here Mg plus 2, it is going to convert into Mg. So when it is going to convert into Mg by taking 2 electron, means 2 moles of electron. By taking 2 moles of electron, it is going to convert into Mg. Means, so here 2 into 1 mole of electron charge how much? 96,500 coulombs. So when we are passing 2 into 96,500 coulombs, how much weight of Mg it is depositing on electrode? 24 grams of Mg it was deposited on electrode. So we need electrochemical equivalent of Mg plus 2. Means how much charge we need to pass? 1 coulomb. So if you pass 1 coulomb, then we will get the electrochemical equivalent of Mg plus 2. Then so here if you cross multiplication, then what we will get? 1 into 24 by 2 into 96,500. So here this is the electrochemical equivalent of Mg plus 2. Means finally what we can write electrochemical equivalent means, so here Z equal to atomic weight or molecular weight. If you take the atom, so then we need to take what? Atomic weight. If you take the molecule, we have to take molecular weight. Atomic weight or molecular weight by 96,500 into n factor. So here n factor, it will depend upon the number of electrons. Okay, so here these formula if you substitute in this equation, so here W equal to Z into Q, then what we can write? Q equal to what we can write? Q equal to I into T. Then weight equal to atomic weight or molecular weight into I into T by 96,500 into n factor. So from that we can write one formula. What we can write? Weight equal to, so here atomic weight, or so here atomic weight by n factor or molecular weight by n factor. What we can say? Equivalent weight. Means we can write equivalent weight into I into T by 96,500. We can write 96,500. This is the another formula. Okay, now see here, from this I am going to take this equation. So weight equal to, so I am taking molecular weight into I into T by 96,500 into n factor. From that weight by molecular weight equal to I into T by 96,500 into n factor. Then weight by molecular weight, we can write number of moles I into T by 96,500 into n factor. So what is the relation between number of moles and n factor? So here number of moles is inversely proportional to n factor. Number of moles is inversely proportional to n factor. If ion n factor is more, so it will deposit less number of moles on electrode. Example, I will give an example. Na plus Mg plus 2 and Al plus 3. What is the n factor of Na plus 1, Mg plus 2, 2, Al plus 3, 3. So which has less n factor? Na. So here more amount of more number of moles deposited at electrode. So in that case we can easily identify, so based on the n factor. For example, so here number of moles at cathode by number of moles at anode equal to n factor at anode by n factor at cathode. So this equation also it will use for us. So this is the one of the equation. So how can we write? So based on the this relation, number of moles is inversely proportional to n factor. Next, another one. So for example, if a gas is deposited an electrode, so at that time what is the formula we can write? So we can write one formula. Directly we can write one formula. Volume of gas equal to I into T into equivalent volume of gas. Equivalent volume of gas by 96,500. So this is the direct formula. So with help of this formula we can calculate the volume of the gas deposited at electrode. So here this is about Faraday first law. Next, Faraday's second law. Faraday second law. So what is the meaning of Faraday's second law? Faraday's second law is nothing but when same quantity of electricity, for example these are the two electrolytes, when same quantity of electricity we are passing through the two different electrolytes, then the amount of substance deposited at electrode is directly proportional to its equivalent weight. So here we are passing same quantity of electricity through the different electrolytes. So at that time the amount of substance of different substances is directly proportional to its equivalent weight. So we have one formula. What is the formula in Faraday first law? So here weight equal to I into T into equivalent weight by 96,500. From that what we can write? So weight by equivalent weight equal to I into T by 96,500. This is total constant. We are passing same quantity of electricity. We are passing same quantity of electricity through the different electrolytes. The amount of substance deposited is directly proportional to its equivalent weight. Then if you take the two condition, at that time what we can write, W1 by E1 equal to W2 by E2. So the weight of substance, it will depend upon the equivalent weight of substance. So here this is about Faraday second law. Next we will discuss some problem. Okay, next see here. So previous IIT JEE 2007 question. 4 molar aqueous NaCl is prepared and 500 ml of this solution is electrolyzed. This leads to the evolution of Cl2 gas at one electrode. Then we need to find out total number of moles of Cl2 gas at electrode. And in this electrolytic cell, if the cathode is mercury electrode, then the maximum mass of amalgam. What is the maximum mass of amalgam they are asking. So first, so they have given, in this question they have given concentration of NaCl. How much? 4. So in volume how much is there? 500 ml. First let me calculate number of moles. So what is the formula for number of moles? We have molarity equal to N into 1000 by V in milliliter. So from that we need to calculate number of moles of NaCl. So what is the M into V in milliliter by what we can write? 1000. Then number of moles equal to 4.0 into 500 by 1000 means, so here number of moles of NaCl, how much we got? 2. Number of moles of NaCl we got 2. Now from that, so in that solution how many moles of NaCl is there? 2 moles of NaCl. The 2 moles of NaCl, it will dissociate into 2 moles of Na plus and 2 moles of Cl minus. See here, so this is the NaCl solution. It is present in the electrolytic cell. In that electrolytic cell, what is there? Mercury is the cathode electrode. If mercury is the cathode electrode, at cathode Na plus it will deposit. At anode Cl minus it will deposit. Now at anode, so what is the reaction? How many moles of Cl minus are there? 2 Cl minus. At anode Cl minus it will undergo oxidation by losing 2 electrons. Then how many moles of Cl2 gas we are getting? Only 1 mole of Cl2 gas. Only 1 mole of Cl2 gas deposited, 1 mole of Cl2 gas liberated at anode electrode. Then second question, what? If the cathode is mercury electrode, then what is the maximum mass of amalgam? Then at cathode, so what is the reaction? Na plus it will deposit at cathode. Means how many moles of Na plus is there? 2 moles. 2 moles of Na plus, it will take 2 electron, it will form, and here what is there? Amalgam, Hg. Then it will get 2 NaHg, 2 moles of NaHg. So from that, already what is the atomic weight of sodium? 23. Atomic weight of sodium is 23. What is the atomic weight of mercury? 200. Then here how many moles of amalgam is there? 2 moles of amalgam. Then what we can write? So here 2 into 23 plus 200 means finally we will get how much? 400 means 446. The answer is 446 grams. 446 grams of sodium amalgam, it was deposited on cathode electrode. So this is the one of the previous IIT JEE question. Okay, this is another IIT JEE question. So the question is 1978. A current of 3.7 ampere is passed for 6 hours between nickel electrodes in 0.5 liters of a 2m solution of nickel nitrate. What will be the molarity of the solution at the end of electrolysis? So after completion of electrolysis, what is the molarity of the solution we need to calculate? So what terms they have given in the question? So they have given I equal to how much is there? 3.7 amperes. Next, time equal to how much is there? 6 hours. Always time must be taken seconds. 6 into 60 into 60. Next, what is the molecular weight of nickel? The molecular weight of nickel 59. Here how much? Nickel plus 2 means directly we can take equivalent weight of nickel 29.5. Then we have one. First let me calculate weight of nickel. What is the weight of nickel deposited on electrode? So here E into I into T by 96,500. Then weight equal to 29.5 into 3 into 6 into 60 into 60 by, we can write here 96,500 coulomb. Next, if you simplify this, we will get weight equal to 24.43 grams. So this much weight was deposited on electrode when you are passing 3.7 ampere. 3.7 ampere passed for 6 hours. How much weight of nickel was deposited? 24.43 grams of nickel was deposited. So with help of these weight, now I am going to calculate molarity. Molarity equal to weight into volume. They have given in liters. So here weight into gram molecular weight by gram molecular weight into volume in liter. So molarity equal to how much weight is there? 24.43 into 1 by, so what is the gram molecular weight of nickel? 59. Then what is the volume of the solution? 0.5. The volume of the solution is 0.5. So if you simplify this, the molarity of the solution is 0.828. So this much concentration was deposited on electrode. So they are asking after completion of electrolysis what is the concentration. So what we have to do? Initial concentration minus final concentration. So here this is the change in concentration. Change in concentration equal to initial concentration. How much? The initial concentration, how much is there? 2. 2 minus 1.172 em. So this is another IIT JEE question. So it was asked in 1987. In that question they have given a 100 watts 110 volts of lamp is connected in series with electrolytic cell containing cadmium sulfate. How much cadmium will be deposited by the current flowing for 10 hours? First you can write what are the term was given in the question. You can write, then we will get the clarity. So here watts equal to how much? 100. Volts equal to how much? Given 110. So here we can write ampere equal to what is the formula? Watt by volt. Then what we can write? I equal to 100 by 110. So we got I. Then time equal to 10 hours. 10 into 60 into 60. We have time also. Next another one. So what is the molecular weight of cadmium? The molecular weight of cadmium is 112.4. Next here what is the N factor? 2. The N factor of cadmium is 2 in cadmium sulfate. Then you can calculate weight of cadmium. Weight of cadmium equal to what is the formula? Atomic weight. So here atomic weight into I into T by n factor into 96,500, then weight equal to 112.4 into I equal to 100 by 110 into time equal to 10 into 60 into 60 by 2 into 96,500. Then if you simplify these, you will get 190.67 grams. So here this is a simple question. So in the question directly they did not give amp current. So by giving the watts and volt means, so in the given question if they have given watt and volt, then what we have to do, ampere equal to watt by volt. So here this is the logical question. Okay, next another question, it is somewhat different. The current efficiency of electrodeposition of copper metal, in which 9.8 grams of copper deposited by passing current how much, 3 amperes for how much time, 10,000 seconds from aqueous solution of copper sulfate is about. Means they are asking about current efficiency. To calculate the current efficiency we have one formula, weight equal to, so here atomic weight into I into T into n is nothing but current efficiency by 96,500 into n factor. We need to calculate the current efficiency. How much weight was deposited? 9.8 grams of copper was deposited. So what is the atomic weight of copper? 63.5. I equal to how much? I equal to 3 into time equal to 10,000 into current efficiency by what we can write, 96,500 into. So what is the n factor? Copper sulfate solution means copper n factor is 2. Then n equal to 9.8 into 96,500 into 2 by 63.5 into 3 into what we can write, 10,000. So from that we will get n equal to 0.99. Then what is the percentage? 99%. Okay, next question. This is IIT JEE 1981. Now a current of 1.70 ampere is passed through 300 ml of 0.16 molarity of solution. So that is what electrolyte zinc sulfate for how much time? 230 seconds with a current efficiency how much is there? 90%. The current efficiency is 90%. Find out the molarity of Zn+2 after deposition of zinc and assume the volume of solution remain constant. During electrolysis the volume of the solution is remain constant. So they are asking after electrolysis, so what is the concentration of Zn+2 in the solution? First let me calculate. So with help of this volume and molarity, first we need to calculate weight of the Zn+2, initial weight of the Zn+2 in the solution. Next, after this current efficiency and ampere with help of time, we need to calculate so how much weight of substance deposited on electrode. Then we will get the final weight of the Zn+2 in the solution. With help of that we can calculate the molarity of the Zn+2. Now, so what is the formula? Molarity equal to weight into 1000 by gram atomic weight into volume in milliliter. So from that we need to calculate the weight of the zinc. So here initial weight of the zinc in the solution before passing electricity. Then molarity equal to how much is there? 0.16. Gram atomic weight 65 into volume equal to how much? Volume equal to 300 by 1000. So here 0 cancel. So from that we will get the initial weight of the zinc is, if you simplify these, we will get 3.048 grams. So here before passing electricity through the solution, how much weight of Zn+2 is there? 3.048 grams. Then how much weight of zinc was deposited on electrode after passing electricity. So what is the formula to calculate that? So here equivalent weight, otherwise I am going to take weight of gram atomic weight of zinc into I into T into current efficiency by here 96,500 into n factor. So next from that what we can write, weight of zinc deposited on electrode, atomic weight how much, 65 into I equal to 1.70 into 230 seconds into current efficiency how much they have given, 90% means directly I am going to take 0.9 by 2 into 96,500. So if you simplify this, you will get weight of electrode at Zn, weight of Zn plus 2 at electrode 0.1157 grams. Next, so remaining weight, how much weight is left over in the solution? How much initial weight, how much is there? 3.048 minus how much weight was deposited on electrode, 0.1157. Then remaining weight equal to how much? 2.9323. So here this is the remaining weight. So with help of this weight we need to calculate the concentration of the solution after passing electrolysis. Now molarity equal to, what is the weight? 2.9323 into, so here what is the 1000 by, what is the gram atomic weight of zinc? 65 into, what is the volume of the solution? 300. So then we will get the molarity equal to, if you simplify this, we will get 1.53 into 10 power minus 1. So here this is the final answer.